rotation kinematics, but the thing that we concentrated on it will be about solving questions, right? So let's solve questions on the rotation kinematics. So on the first question says a bike wheel rotates with a constant angular acceleration of 3.5 rad per second. The initial angular speed of the wheel is 2.0 rad per second at t is equal to 0. So the first question says through what angle does it rotate in 2 seconds? So the first thing that you have to do is get the data. So you have to get the what? The data. So in this situation, you have the angular acceleration. So meaning it's alpha 3.5 rads per second square. What else? You have again the angular, the initial angular what? The initial angular velocity. Omega is equal to what? 2.0 rad per second. Yeah, so these are the things that you're having. Then what are they asking? Through what angle does it rotate in 2 seconds? So meaning that they're saying through what angle does it rotate in how many seconds? 2 seconds. So meaning that you're looking for the distance at which it traveled. Since they're saying through what angle, so meaning it's the distance through which what travel. So it will be theta is equal to omega initial plus 1 over 2 alpha t squared. So what's the initial alpha or initial velocity? It's 2.0 like that. Then what's the time that have been given? The time they've given us is 2 plus 1 over 2. What's the alpha? You find that the alpha is 3.5, then the time is 2 squared. Then you end up to have what you say 11. So after you've done everything here, you end up to have 11 rad like that. So that's the answer for question 1. Then for question 2, they're saying find the angular speed at the wheel at t is equal to what? To 2 seconds. So how are you going to find the answer there? So there you say omega final is equal to omega initial plus alpha times t. What's the omega final? So the omega final in this situation we haven't been given, right? So meaning that what are you going to do in this situation? So now is the one that you're looking for. So meaning what's the initial? The initial is 2. Then what's the alpha? The alpha is the one that is 3.5. This is 3.5 there. Then times 2 seconds. Then your answer will have what? 9. What are the units? It's rad per second squared. Rad per squared like that. So those are the what? The angular speed of the wheel. Now let's go into the another one. So the another one is saying that a flop disk in a computer rotates from the rest up to an angular speed of 3.14 rad per second in time of 0.892 seconds. What's the first question? So the first question says, what is the angular acceleration of the disk, assuming the angular acceleration is uniform. So the first thing, as I said, that you have to take the data. So let's take the data in this situation. They're saying that the flop disk rotates from the rest up to an angular speed of that. So what's the angular speed? The angular speed of 1.4 rads per second. So I want you to understand, if this thing it came from the rest, so if it came from the rest, meaning what would be our initial be 0, because it started from the rest, so it would be 0 second squared like that. Then what else? Then the time they have also given us, which is 0.892 seconds like that. So what's the question they're saying? What is the angular acceleration of the disk, assuming the angular acceleration is uniform? So what are you looking for? You're looking for the angular acceleration. So in that type of equation, which is the first one, we have to say angular velocity final is equal to angular velocity initial plus alpha times t. Then what's the final in this equation? This is the 1.4. The initial will be 0 because it started from the rest. Then what's the angular? Is the one that you are looking for, the angular acceleration. And what's the time? The time is 0.892. Then this is the 1.4. Then here it will be 0, meaning that it will be 0.892 alpha. Then you find the alpha. This one and this one will divide, meaning that what will be your answer? Your answer will be 35.2 rads per second squared. Remember what you're calculating here, we're calculating the what? Angular acceleration. Then let's do the next one. They're saying how many rotation does the disk move while coming up to what? To speed. So meaning that we're looking for the acceleration, right? So for the rotations or the angle or the displacement. So how are you going to find that one? So you say theta there is equal to omega initial plus 1/2 square there. Then what's the omega initial? Remember it's started from the rest, so it'll be 0. What's the time? The time is 0.892 plus there 1/2. What's the alpha? It's 35.2. Then what's the time? Just the same one, then you square it, which is just okay. Let me just create some more space. Okay, I'll say theta 1, that's theta omega initial times time plus 1/2 alpha squared. Then what's the omega initial? The omega initial here in this situation is 0 because it started from the rest. How about the time? That's 0.892 plus 1/2. What's the alpha? The alpha is 35.2. Then what's the time? The time is 0.892. Remember here it's squared like that. Then what should be your displacement in this situation? So in this situation, your displacement will be 14 rads, just like that. So that's how you calculate this type of the situation. Now let's go into the another question, which is question 3. So what is the question 3 saying? So question 3 is saying that if the radius of the disk is 4.445 centimeter, find the final displacement of the microgriding on the rim of the disk. So in this situation, what are you supposed to do in this situation? So remember here we are converting from the what? From the angular to the linear speed. So how do we convert it from the angular to the linear speed in this situation? Because they're saying find the final linear speed. Find the final linear what? Speed. Meaning that it's the linear. So meaning it's supposed to be V is equal to what? Omega, like that, is equal to V omega times R. So what's the omega in this situation? Remember it started from the rest and it ended on what? 31.4. So it will be 31.4, which is right per second. Then what's the radius? The radius that have been given in this situation is this one, which is 4.45 centimeters. Remember that is in the centimeters, so we have to divide that by what? By 100, so that we can have what? We can have it in meters. So it will be 0.0445. So this happens after you have divided that one by 100. Then your answer will come to 1.4 meters per second, like that. How about the other one? The other one that's saying, what are we calculating? tangential. So remember that how do you calculate the tangential acceleration? Meaning that you're calculating the acceleration that is in the what? In the linear. So it means to be in the linear means that what? Acceleration is equal to alpha times what? Radius. So what is the alpha? The alpha that we calculated, if you remember properly, we calculated the alpha on the first question, which is what? 35.2. Then what's the radius? The radius is the same one, which is 0.044, then 5, like that. Then you have an answer which is 5.7 meters per what? Per second squared, like that. So that's how you answer this type of the question. Okay, let's go on question C. So on question C, they are saying that a wheel starts from rest and rotates with a constant angular acceleration to reach an angular speed of 12.0 rad per second in 3.00 seconds. Find the magnitude of the angular acceleration of the wheel. That's the first one. So what are you supposed to do in this situation? Get the data. So the wheel, they're saying, they said the wheel starts from what? From rest, meaning the angular speed in this situation will be 0, or initial velocity it's 0, right? So up to what speed? Up to 12.0 rad per second. In what time? That is 2 is equal in 3 seconds, in short. So in this situation, they are saying find the magnitude of the angular acceleration. So how are you going to calculate that one? That's where you have to say what? Omega final is equal to omega initial plus the alpha times t. So what's the final here? This is 2. So it's 12. There, remember, it's 0. We're looking for the angular acceleration. Excuse me. And what's the time? It's 3. Like that. So if you have that, meaning here to be 12 there, meaning the 3 here, alpha, divide by 3, divide by 3. And this they'll go. Then what are you going to have? We are going to have 4 rads per second squared, like that. So that's how you answer the first question. How about the second question? They're saying the angle in the radian through which it rotates. So meaning that you're calculating the angle in radian through what it rotates. So to be theta is equal to omega initial plus 1 over 2 at squared, like that. What's the omega initial? So the omega initial, remember, it's 0, like that. Then what's the time? The time they've already given us, which is 3. The angular, that's 4. Angular, or the alpha, the angular acceleration. The time is 3, which is squared, like that. Meaning here to be 0 plus, after calculating everything there, you have to get plus what? 18, right? So meaning that we have 0 plus 18, it will give us what? 18 rads. So that's how you calculate what? You calculate that one. So let's go on the another question, which is question D. So question D, they're saying the tap of the washer goes in its span cycle, starting from rest and gaining angular speed steadily for 8.00 seconds, right? At what time is which time is it turning at 5.00 rev per second? At this time, the boat, at this point, the person doing the laundry opens the lid and safely switch off the washer. The tap smoothly slows to rest. In how many seconds that it is? 12 seconds. Through how many revolution does the tap turn? Well, it is what? In motion. So here, the fastest way on how you can do this one is this one. Just use this part. If you look in this situation here, right, they're saying that a tap of a washer goes in its span cycle, starting from rest and gaining angular speed steadily for 8 seconds, meaning that it started speeding up. For what speed? Started speeding up in how many seconds? In 8 seconds. So meaning that we have 8 seconds up to what speed? That is 5 rev per what? Per minute. So in 5 rev per minute, in how many seconds? 8 seconds. Then from there, at this point, the person doing the laundry opens the lid and the safe switch turns off the washer. The tap smoothly slow to rest in how many seconds? 12 seconds. So meaning that you have this another trip which was going down for how many seconds? 12 seconds. What was the speed? The speed here, it was 5 rev per what? Per minute, like that. So here the speed slowed down in how many seconds? From 0 to what? To 12, like that. Now they're saying through how many revolutions does the tap move? Well, it is in what? In motion. So when it was starting here, it was in motion. When it was coming down here, for 12 seconds, it was in motion. So what are you going to do in this situation? For you to calculate the whole distance, the one that were in motion, what are you going to do? Remember that this is the triangle, so we need to just do what? 1 over 2 BH, the one that was moving, speeding up, plus 1 over 2 BH, plus the one that is what? Was slowing down, the motion that was slowing down, like that. In this situation, the motion that was slowing down. So meaning that your answer will be 1 over 2, like that. Let's start with this part. So what's the H, the B? It's 8. How about the height? Is 5 plus 1 over 2. How about the B is 12. How about the height is 5? You find that your answer, you have this side, you have 20 plus 30. Then your answer will come to have 50 rev per what? Per minute. Just like that. Then let's do the next question. Then the next question is saying the driver train of a bike that has the wheel 67.3 centimeters in diameter and pedal crank which is 17.5 centimeters long. The cyclist pedals at a steady rate, angular rate of 776.0 rev per minute. Then they're saying that the chain engaged with a front sprocket which is 15.2 centimeters in diameter and the rear sprocket which is 7.0 centimeter in diameter. The first question they say calculate the speed of the link. Calculate the speed of the link of the chain relative to the what? To the bike frame. So meaning that you are calculating the speed of the chain relative to the what? The bike frame. So remember that the front sprocket is connected to the pedalist, like that, right? This part is the smallest. So it's connected to what? It's connected to the pedalist, right? As this spinning here, right? At the rate of or at the speed of 76 rev per minute. So meaning that the chain was also moving relative to the pedal that was moving at this rate. So how are you going to calculate the speed of the chain, right? So in this situation, what exactly was moving the chain? It is this front what? Sprocket. So this front sprocket, which is this part, is connected to the pedal, to the pedalist, right? To the pedal crank, in short. So this pedal crank, as it moving, it moves the front sprocket, which is this part, right? Then this front sprocket is the one that moves the chain, right? So meaning that if we have the radius of the front sprocket, meaning that we can calculate the speed of the chain at which it was moving. How? That's where you have to say, question 1, we say here, did they say to have to calculate the angular? I've just said the velocity, meaning that you have to calculate the velocity. So the velocity is equal to angular velocity, or alpha there, like that, right? Or alpha there times the what? Radius. Which radius? The radius of the front sprocket, because it's the one that is moving the chain. So in this situation, we have the diameter of the front sprocket. So let's see, find the radius of the what? Front what? Sprocket. So how do we find the radius in that situation? So in that situation, we say 15.2 centimeters. You divide that by 2. So when you divide that by 2, what are you going to get? You get something like 76. You get something like 76. So after getting that, you need to divide that one again by what? So for example, in that situation, you have 15 there, 15.2 divided by what? By 2, so that you can have the radius. So you get something like a 7.6 centimeters. So from there, now let's convert this one now from centimeters to what? To meters. So meaning that when you divide that by 100, it will give you what? 0.076 meters. So we have found the radius. So the radius that we have found is 0.076 meters. So that's a radius of the front sprocket. Now the next thing, you have to calculate the what? The omega. So the omega is it has been already been given, which is 76.0 ref per minute, but we can't use that one because we have the meters here. So meaning that because we have the meters here, meaning that we have to convert that one to rad per second. So how are you going to find rad per second? So that's where you have to say, to do this one now, you have to say what? You have to say 1 rev is equal to 2 pi radians. How about 1 minute is equal to 60 seconds? So 1 into 1, it will give you 1 rev a minute. But 60 into 2 pi, it will give you 0.105 right per second. So this is 1 rev per second, or this is 1 rev per minute. This is equal to 0.105 rad per second. Remember, we're converting this to rad per second, so it will be 76.0 rev per what? Per minute is equal to x, such that your x will be equal to what? Will be equal to x will be equal to what? So it will be 76 times 0.105. So your answer will be 77 point what, or 7.96 after you have multiplied that. So meaning that this is your now your what? Your angular speed. So you have the angular speed here. So from there now, what you're gonna do, you will multiply so you have the angular speed, which is 7.96. What's your radius? 0.76. Then your what will be the answer in this situation? Your answer in this situation will be 0.0605. That is in meters per second, like that. So that's your first equation. That's your first answer. So the second question is saying calculate the angular speed of the bike. Calculate the angular speed of the bike wheel. So remember that this rare sprocket is the one that is connected to it. So meaning that the rate of the rare sprocket is equal to the speed of the tire, because the rare sprocket, which is the small here, the small right, it is equal to the speed of the what, of the tire. So how are you going to find that one? Remember that this rare sprocket is the one that is being moved by the what, by the chain. So meaning that if the chain is moving at this rate, this is 0.00605. So if the chain is moving at that rate, So they're saying that calculate the angular speed of the what? Of the bike wheel. So here we're calculating the angular speed of the what? Of the bike wheel. So how are you going to do that one? Remember, we're converting from the linear now to the what? To the angular. So to be that which is it? Alpha, oh sorry, omega is equal to what? Velocity over radius. So which radius now? It is of the rear sprocket. What is the speed? We get the speed of the chain over what is the radius? The radius of the rear sprocket is, they have given us the diameter, which is this part. So this diameter now, we convert that diameter into the radius. So we have to divide that one by 2. So 7 divided by 2, it will give us 3.5. Then after that, you have to divide it by 100 so that it can be what? In meters. Then your answer here to be 0. What? 0.5, like that. Then from there now, you have to divide that one so that you can calculate the what? The angular speed. Then your answer, after doing that, oh, here it's supposed to be 0. After you have divided that, it's supposed to be 0. What? 0.005, like that, right? 3.5 divided by 3.5 divided by 100, like that, right? Now from there now, you find something like 17.3 right a second, like that. So that's how you calculate on that one. Let's calculate the last one. Calculate the speed of the bike relative to the what? To the road. Now, which one works in the road? It is the tire itself, which is this tire, which is itself. Now, meaning that here now we have to say V again to, which is V angular here, are like that. Then what's the angular velocity? We have found that it already is what? 17 here. Then what's the radius of the tire? The radius of the tire, they have given us the diameter, so it will be, we have to convert that one, 67.3 divided by 2, so it will give us 33.65. Then divide that by 100, so it will give us what? 0.3365, like that. Meaning that when you multiply by that by 17.3, it will give us 5.79. So that's meters per what? Per second, like that. So that's how you calculate that in a simplest way. Now let's go on the next question. So on the next question, they're saying a ball of mass 0.500 kgs is attached to the end of a cord 1.5 meters long. The ball is wheeled in a horizontal circle as shown in the figure below. If the cord can withstand a maximum tension of 50.0 newtons, what is the maximum speed at which the ball can be wheeled before the cord breaks? Assume that the string remains horizontally during the motion. So how are you going to calculate that one? Let's take the data. So they have been given the tension in the force, which is 50 newtons. Then what else? The mass 0.500 kgs. When what else? That one, it will represent the tension, right? Or that one to represent, or the length, it will represent the what? The radius, which is 1.50 meters. So what are they asking? They're saying what's the maximum speed which the ball can be wheeled before the cord breaks. Assume that the string remain horizontal during the what? The motion. So in this situation, what are you supposed to do in this situation? So in this situation, you have to say, remember those formulas. Acceleration is equal to what? Is equal to v squared over what? Over radius. So how are you going to find the acceleration? So we can find the acceleration by saying force is equal to mg. So what is the force? It's 50 there. Then what's the mass? 0.5, right? acceleration is sorry, meaning here you can find 0.5 there, then you divide by 0.5, and you divide by 0.5, meaning that this will divide. What are you going to remain with? You're going to say A is equal to what? 200 meters per second squared. Then after that, you have found that your answer is what? 100. That's your acceleration. Then the velocity is r. What's the radius in this expression? The radius is 1.50. Then you make v to be what? Subject to formula. This time that it will give you what? 150. And then you can calculate the velocity. So how are we going to calculate the velocity in that situation? So you calculate the velocity by that situation, you say, meaning that you answered what? After finding the square root of 150, it will be 12.2 meters per what? Meters per meters, just like that. So this is how you calculate that question. So what's the next question? The next question, they're saying that a jet is flying at 134.1 meters per second along a straight line and makes a turn along a circular path level with the ground. What does the radius of the circle have to produce a centripetal acceleration of this, which is acceleration due to the what? Gravity on the pilot, and the jet toward the center of the what? Of this. So remember, acceleration is equal to v squared over radius. So the acceleration due to the gravity, let's add 1 like that. What's the velocity? The velocity is 134.1 squared over radius. So this time that is 9.81, r is equal to 134 point squared, which is that, and you divide here 1, divide here by 1. This and this, they'll go. What's your radius? So your radius in that situation will be 134.1 squared divided by 9.81. So you will find something like 1833 like that. So it's meters like that. So that's how you calculate that one. Now let's go into the last question. So on the last question, they're saying the passenger on the bus rides move at a constant speed, makes a turn on the roundabout of the radius 5, making a complete circle in 4 seconds. What is the acceleration? So in this situation, you need to calculate the angular velocity. We use this method. The period is equal to angular velocity, like that, right? What is the period? The period is 4, 2 pi over theta over 1. Then this one times this one, it will be what? 4w is equal to 2 pi over 2 over 2. Then pi will be, remember that what are we looking for? We're looking for what? For angular velocity. So 2 pi, your answer will be 1.57 rads per second, like that. Then after finding this, you go and calculate now the what? The velocity. So how are you going to find the velocity? By saying the linear velocity, by saying radius, like that, right? What's the radius? The radius is 5 times 1.57. Then what will happen? It will be 5 times what? 1.57, like that. Then you find 7.85 meters per second, like that. And then now the acceleration is v squared over radius. So the velocity we have already found, this is 7.85 divided by, what's the radius? The radius is 5. So you have just to square that one, you divide by 5. Then you find something, the radius, which is 12.3 meters per second squared. So this is how you solve your question. So the next time that we meet, we shall do something else that is good.